Okay, so we are recording, and let's do a quick review of our linear relations. Just going to make sure our recording is working well, and looks like it is. Okay, so linear relations review. We're looking at straight lines and how to graph them, how to deal with them. One important thing to remember whenever we're looking at straight lines is we need to know how to use a Cartesian grid. And to use a Cartesian grid, we need to know a couple of important things about it. We need to know that we have one axis called our x-axis. It's this one right here. We need to know that we have another axis called our y-axis. Should do that in a different color. It's this one right here. So those are our two axes. That's how we can talk about where things are on our, we call this a coordinate plane, where they are on there. And of course we label them with numbers, and each side of the axis is a positive and a negative one. So it says, first of all, label the coordinates for point V. So I'm going to write point V. That's this one right here. And I want to label my coordinates for it. So the first coordinate I'm going to label is my x coordinate. So I have to see how far over I am in terms of x values. 1, 2, 3. Looks like that's how far over I am. So I'm going to have an x coordinate of 3. And now it's my y coordinate. How far up am I? Looks like 1, 2, 3. Looks like it's also 3. So my coordinate is 3, 3. So I can write v, 3, 3 like that, indicating I know where that point is on my Cartesian graph. Right now, I would like you to have a look at this, and I would like you to identify where W is. So on here, take a moment and try and identify. You can write it down or just think of it in your head, where W is. Once you feel like you've got that, go ahead and put it in the chat right now. Where is point W? Okay, so I see some answers coming in the chat. That's great. Thanks for posting that, folks. Let's count our x value. We're going in the negative direction this time because we're starting at 0 right here at the origin, and we're going -1, -2, -3, -4, -5. So our x value is -5. What's our y value? Well, we're not going down, so we're not in the negative direction. We're going up, so we're going to be in the positive direction. +1, 2, 3, 4. So a y value of +4. So point W is at -5, 4. Okay, so that's just a quick reminder about how we label things. I see that's what you folks are putting in the chat, so that's great. Awesome. Looks like that's something we're feeling pretty comfortable with. Perfect. Okay, next, let's move on to something that is going to review what we kind of started with in this unit. This says complete the table of values and determine the rate of change. Oh, I also wanted to tell you there's a document attached to EDSB for today. It's right at the bottom. There's actually two things attached to our EDSB agenda for today. And one of them is actually this document that I pulled this from. So if you want to see this, like written out without having to, I don't expect you to be copying this yourself because I'm going to post all of this, but these review questions that I'm going to go through today are already posted on our EDSB agenda for today. So our first one says complete the table of values, determine the rate of change, what's the slope, what's the y-intercept, and write the equation of this linear relation. So I'll give you just a moment to read that over and have a look at it, and then I'm going to dive in solving this question. Okay, So for my x values, when I write x values in a table of values, they always just go in order. And we can pretty much pick whatever we want, and then we just see what the y values are. So in this case, they've been written in order as 0, 1, 2, 3, 4. Okay, so that makes sense. Now with our y values, we have to look and see what our pattern is going to be. It looks like it goes negative 40, negative 30, negative 20. Well, I can figure out what the next one would be. The next one's just going to follow that pattern, and it's going to be negative 10. And then after that, it's going to be 0. So it goes all the way up from negative 40, negative 30, negative 20, negative 10, and 0. It's going up by 10 each time. So it's starting at a negative, but it's getting greater by 10 each time. The next one, of course, would be 5 and 10, because it would go up by 10 more. But we don't have room for that on our table of values, so I'll take that off for now. Now, our rate of change, you might have also heard called first differences. It's also sometimes called first differences. All that means is, how much is it changing from one to the next? To figure out our rate of change, we need to look at our y values and see how they're changing from one to the next. So we say, when we go from 40 to negative 40 to negative 30, what kind of change is that? And I can see that's an increase of 10. It's going up by 10. So my rate of change for that one is 10. Same for my next one, same for my next one, same for my next one. My rate of change should be plus 10 because it's going up by 10 each time for my y values. But there is actually a way to write that out mathematically. Here's how we do it. We take our later one, negative 30, and we subtract our earlier one to figure out the difference. Oops. Pardon me, I need to erase that. Let's just start that over. Here we go. So we go negative 30 is where we ended up. What's the difference between that and where we started? So this looks complicated. Negative 30 minus negative 40. Now subtracting a negative is like adding. So it's really like negative 30 plus 40. Well, that's 10, positive 10. For our next one, we end up at negative 20. Let's subtract the one before it to see how it's changed. Well, negative 20 plus 30, because subtracting a negative is like adding, is 10. And that makes sense, right? Because we can see it's going up by 10. Negative 10 minus negative 20 is 10. And 0 minus negative 10 is 10. So my rate of change tells me that it's going up by 10 each time. Now you're welcome, from where I stand, you're welcome just to look at your y values and see how they're changing. And if you're comfortable just looking at that and saying plus 10 each time, you can just write in the 10. That works fine. If you like to do it with the subtracting, taking the second one and subtracting the one before it, that works totally fine as well. So what is the slope? Well, the slope is just our rate of change. The slope is just going to be how do our y's change from one to the next. So our slope is 10. But instead of just writing 10, why don't I use the variable for slope? What's the variable that we use to represent slope? Well, the answer is we use m. M is the letter that we use to represent slope. So I'll say m is 10, because that's the letter we use to represent slope. What's the y-intercept? What's the y-intercept? Well, how do I tell a y-intercept? If I had a graph, I could just look at where it hits the y-axis. That would be easy. But I don't have a graph. So how can I do it just by looking at my table of values? Well, here's how I can do it. All I have to do is look for where x is 0. Because where x is 0, that means it's going to be hitting the y-axis. So where x is 0, y is negative 40. So that's the one I'm looking for. I'm just looking for where x equals 0. So I say, okay, let's put that in. In brackets here, we'll say, where is x equal to 0? Question mark. The answer is at negative 40, at a y value of negative 40. So what's our y-intercept? We say our y-intercept, and we label that as a b. We call it a b. b equals -40. So I've got my slope, I've got my y-intercept. What's the equation of this linear relation? Well, here's how we write an equation. We write it as y equals the slope times x plus the y-intercept. So what's that going to look like in this case? Well, our slope is 10, so I'll put in a 10, and my y-intercept is -40, so I'll put in a -40. So y equals 10 times x minus 40. And I could go into Desmos and I could graph this and I could see what it looks like. Now this is very similar to the question you're going to do on part 1, or the very first question when we do our review in your workbooks today. This one is going to be very, very similar. Okay, so I'm going to save that. Now I do actually have the answers over here that I'm going to also pull out. They're the same as mine, but I'm just going to put them down here below because these are the official ones out of the answer guide. So they look the same as the ones that I did. Okay. Let's go on to our next one. We got a few of these. Here's our next one. Jeff shovels the driveway for his neighbors. His potential earnings are shown in the table. If he shovels 0 driveways, he makes $0. That makes sense. If he shovels 1 driveway, he makes $8. If he shovels 2, he makes $16. If he shovels 3, he makes $24. If he shovels 4, he makes $32. So we've got a couple of things we're going to try and solve here. We're going to try and figure out the rate of change, which is also the slope, in Jeff's earnings for each driveway shovel. We're going to graph the data from the table, and we're going to determine the slope of the line. Okay, so here we go. Let's do our rate of change. My table isn't really set up to show that, so instead I'm just going to use little arrows like this to show my rate of change. Also, this is sometimes called the first differences. That's a term you might hear. So how do I figure this out? Well, I can see, it looks to me like it's going up by 8 each time. So I should have a rate of change of 8. But let's just do our subtracting just to make sure. My first one, I go 8 minus 0. Well, that's going to be 8 minus 0 is 8. My next one, I go the lower number, lower down on the table, 16 minus the one before it is 8. 16 minus 8 is 8. And we got 24 minus 16. Well, that's 8. And 32 minus the one above it, 24. That's 8. So I think you see the pattern here. What is our rate of change? So I can say, okay, my rate of change is also my slope. Well, that's actually a later question, so I don't want to write that in here yet. My rate of change, I'll just say ROC, rate of change is 8. Now, if we were to graph this, I can't actually go to Desmos with you right now because I'm recording this, and I don't have my second screen anymore because I'm not at the school. So I'm just going to bring out my solution here, and I can see here's my graph. Driveway shoveled is on my x-axis and earnings is on my y-axis, and I can see it's a straight line. If I were to put these points into Desmos by making a table and writing the points in, it would be easy to see that this is a nice straight line. Now it would also save me the trouble of having to actually graph it out on paper. So I'm going to leave that there for you to look at later. And C says determine the slope. Well, the slope is just the same as the rate of change. They're the same thing. So I'll say my slope is 8. Nice. Okay. Let's try our next one. Here we go. For each graph, determine the rise and run between the pairs of points shown, then calculate the slope. So we're going to do rise and run. When I'm looking at this graph, right away, I'm going to say, okay, I got my 2 points here, right? One's right here and one's right here. We can use any 2 points. In this case, they happen to be given to us, which makes it nice and easy. But if we weren't given the points, that's okay. We just need to pick any 2 points on the line, and any 2 points will work. Let's figure out our rise and our run. Here we go. Our rise is how far up we go. So let's just look here. We go, looks like we go up to 2 and then to 4. Now you might be thinking I should count 1, 2, but that's not the case, because you can see right here on the axis we've got a 2. So each box on our grid represents 2, not 1. So we've got to be a little careful of that. So we go from 0 all the way up to 4. So this is a rise of 4. And what's our run? We start over here at -2. We go to 0. And then we go to 2. So it looks like that is also 4. Looks like we have a run equal to 4. So I'm going to say slope equals rise divided by run. My rise is 4. My run is 4. So instead of leaving that as a fraction, 4 divided by 4 is just 1. There we go. So I've got a slope of 1. Nice. All right, let's have a look at our next one here. This one I notice also has a positive slope, meaning as I go from left to right, like reading a book, it's going up. It's got a positive slope, so it should have a rise that's positive. So let's do rise and run here. Again, we've got a grid here that goes up by 2 each square, so we've got to be careful of that. So, oops, my pen's a little, that's better size. Okay, so what's our rise? Well, it looks like we go from 2 to 4. So our rise is going to be from 2 to 4. That's a rise of 2. This is our run, 2, 4, 6. Looks like our run goes from 2 to 8. That's a run of 6. So our slope equals rise divided by run. That's rise of 2, run of 6. Now am I done? Nope, I'm not. Because I can simplify this fraction. 2 over 6, well, I can divide them both by 2 to simplify my fraction. 2 divided by 2 is 1. 6 divided by 2 is 3. So 2/6 and 1/3 are equivalent fractions. So I can write this in a simpler form as 1/3. Okay, so that's finding my slope from a graph. Now remember, if I had a bar that was going down, I'd do it exactly the same, a line that was going down, I'd do it exactly the same, but my rise, instead of being positive, would be a negative number. So I would end up with a negative slope. And there's my answers here. Okay, got 4 more to do. Some of these are going to go pretty quick. Oh yeah, wanted to do this one. I think we'll move this one to the end because I wanted to do this one with Desmos. So we'll move that one to the end and then we'll use Desmos for that. Okay, here's one that says determine whether the lines represented by each pair of tables of values are parallel. Well, this is a tough one. Parallel lines, remember, mean lines that never touch each other. So they go like this, and they go on to infinity and never touch each other. They're parallel. Those would be parallel lines. So how do we know if lines are parallel? Well, here's how we can tell. A parallel line will have the same slope. It's going to have the same slope. So if their slope is the same, that means they're parallel. So I need to figure out the slope. If I can figure out the slope, I can tell that they are parallel. Okay, so let's have a look at our y values here and do some first differences. That's going to tell me their slope, and that'll tell me if they're parallel to each other. Okay, so here's my first one. 10 to 13. That's going up by 3. 13 to 16, that's going up by 3. 16 to 19, that's going up by 3. How about my next one? 0 to 1, that's going up by 1. 1 to 2, that's going up by 1. 2 to 3, that's going up by 1. -5 to -10, that's actually going down. It's going down by 5. -10 to -15, that's down by 5. -15 to -20, that's down by 5. How about this one here? -1 to -6, that's going down by 5. -6 to -11, that's going down by 5. -11 to -16, it's going down by 5. So what did I learn from this? Well, I can tell that by looking at my first one, the slopes, first one has a slope of 3, the second one has a slope of 1. These are not the same. So not parallel lines. What about my second one? Slope is -5, slope is -5. Right? We also call that the rate of change. So it's the same, therefore those are parallel. They have the same slope. So those are parallel lines. If we graph them, they would never touch each other. So we've got some parallel lines for B, not parallel lines for A. You can tell that just by looking at the slope. Okay, here's our next one. This one is an equation writing one. So I think we were getting to the point where we were pretty comfortable with this. It says write the equation for each line given the slope and y-intercept. Now remember, a slope can be given a couple of ways. We could write slope, we could write m, we could write rate of change. Those all mean the same thing. Okay, for our y-intercept, we could have y-intercept, or it could be written as b. Those are all the same thing. So knowing that, we'll just put that up there. Now we need to find an equation for each of these. Well, here's how we do that. We remember an equation is written by saying y equals mx plus b, where m is our slope and b is our y-intercept. So let's write each equation here. We can start with y equals for each of them. And for my first one, I'll always have an x there. Now what do I put in front of the x? Well, I put the slope. So my first one is a -3. The second one is a -0.75. Let's see if I can make that fit, just barely. Then I've got a slope of 4. This one has a slope of -1, so I'm just going to write negative because we don't usually write the 1. But it means the same thing. Now this one has a y-intercept of 0, so I'm not actually going to write +0 because that wouldn't change it. So I'm just going to leave it as y equals -3x. And I know that means a y-intercept of 0. My next one has a y-intercept of 0.5, so I'll put plus 0.5. My third one, C, has a y-intercept of 4, so I'll put a +4 on the end. My last one has a y-intercept of 0, so instead of writing a +0, I'll just leave it like it is. There we go. We've written an equation for those lines based on the slope and the y-intercept. We just have to plug them into the proper spot. Let's get our solutions here. There we are. Okay, last one I want to do with you, and then I'll just do a quick little bit of graphing for those ones we wanted to graph. Take a moment to read this over, and then we'll jump in together. Okay, so we've got a couple things to do. First, we got to complete our table. Then we need to graph this. Then we need to write an equation. And then we need to say how many seconds does it take to complete lap 7. So let's grab our first solution here. Here are different lap times. I'm going to shrink this down a little bit. So each lap takes a little longer than the one before. So the first lap he can do in 20.5 seconds. The second lap he's a bit more tired, so it takes 2.5 seconds longer. So it's 20.5 plus another 2.5 seconds. That's 23 seconds. The next lap, it takes him 2.5 seconds longer than that, so 25.5. Then 28, then 30.5. Okay, so it's going to take him a little longer each time. Now, if we were to graph this, I would recommend, considering we're doing learning on a computer right now, or a device, that you would just use Desmos. We'd plug these into Desmos, and again, I'll review that with you in a little bit. But what we'd end up with is a graph that looks like this. There's our graph. Okay, so we'd end up with a graph that looks like this, with his lap number on the x-axis and his time on the y-axis. So that's what it would look like if we were to graph it. We could use Desmos to do that. Now, to write an equation, we're going to need to know a couple of things. To write an equation, we're going to need to know what is his slope and what is his y-intercept. Okay? What is his slope and what is his y-intercept? Well, by looking at the graph, it looks to me like each time when we go from one point to the next, I'll just pick these 2 points here. We've got a rise of 2.5 seconds. And we've got a run of 1. So a rise of 2.5, a run of 1. Okay, So to get our equation, that means our slope is going to be 2.5 divided by 1, right? Because it's rise over run. 2.5 divided by 1 is 2.5. So that's our slope. What's our y-intercept going to be? This point right here. That's a little tricky. Well, if we use Desmos, we could just plug in a 0 into our table of values, and we could get that. It would help us out with that. But let's try and do it just by looking at the graph. It looks like we can take the point before and just go down 2.5. So where did we start? Well, we started at 20.5. So let's go down 2.5 from 20.5. Let's go 20.5 minus 2.5. That's going to put us at 18. That's going to put us at 18. So we'll say, okay, our y-intercept would be 18. So what's our equation? Well, it's y equals mx plus b. There's our equation. 2.5x plus 18. So if I want to figure out lap 7, I can use my equation. What I can do is I can take my equation, and where that x is, I can put in a 7. And I can actually do this to figure out the time for any lap he's going to do. So it allows us to make predictions about stuff really easily. So let's do that. 2.5 times 7, of course, bed mass, right? Tells us we got to multiply first before we add. So let's do our multiplying first. So 2.5 times 7 is 17.5. And then we go 17.5 plus 18, that's 35.5 seconds. So that's a pretty tricky one. Got to fill in our table of values, got to do a graph on Desmos, need to look at what our y-intercept is going to be, need to figure out what our slope is going to be to make our equation, and then use it to make a prediction about further laps down the road. Pretty tricky. Okay, so folks, I'm going to end this review video here, but what I'm going to do now is I'm going to go to Desmos, and I'm going to share my screen with you, and I'm going to take you through this question 4 and 5, okay? So I'll stop the video now, and then we'll try questions 4 and 5 there.